Hey guys, welcome back to the second part of eBPF programming. And this second part we'll be exploring a bit more on Linux security modules with the eBPF. And here I'm going to share my experience on how I developed a detection app in eBPF that detects self-deleting malware behavior. And a bit on LSM, it's a framework in the Linux kernel that allows different security modules to be implemented as a loadable kernel modules. That's the main point. If you want to implement normal LSM based applications or whatever it is, you have to make it as a loadable kernel modules, and that's a difference and beauty of eBPF. You don't need to make it as a kernel module. You can make it as like an independent program. And these are the core concept. As you know, maybe you are familiar with SE, Linux and AppArmor. That basically implemented this LSM. And hooks are the main area that LSM provides to us, and we have to implement our logic on the hooking area, hooks. And I will show you where I did put my hook and how did I detect the self-deleting behavior of the malware. And these are some processes that LSM going on, like it has initialization, registration, and it has security checks that checks the security checks triggers on the hooking point where we put our logic, like opening a file, deleting a file, or some other network events. You can place your hooks wherever that LSM is providing. Actually, LSM has a list of a heavy list of hooks that you can make use of in your application. And normally it will be in a Linux kernel module. You have to make it as like a loadable module. And when you integrate this LSM and eBPF, here is the main thing, like the thing that I did here. Actually, LSM, as I mentioned, LSM provides hooks in the kernel where security modules can perform checks, and eBPF can be attached with these hooks. That's the main area. So I did the same thing. Like I had taken one particular hook for my application function, and I attached my eBPF to these hooks. So, and I did additional checks on there, and yeah, it was not a smooth journey for me because it is first time I'm digging deeper into the Linux kernel part, especially the kernel programming side, and exploring, digging more deeper into this one because it's really addictive and it's really funny programming. And yeah, with this one you can create dynamic security policies based on LSM. I haven't checked any prevention stuff till now, but I think you can do preventive some applications that you can make using not really detection. Maybe you can prevent the attacks also, but I didn't check that. I have to. Maybe in future I'll definitely do that. And this is a way the eBPF enhances LSM. Like you can have your own custom security policies, and yeah, of course eBPF helps us to real-time monitoring and enforcement that I showed on my last video how it works on normally how we can trace system goals and how we can monitor system what's going on the system by hooking wherever we want to put the trace point. We can watch the trace point, and last video I have shown you that system ender and I think unlink. I don't know. We just check the system ender exec system goal and how we can trace that and check and access details what's going on the machine based on that. And these are the other use cases that you can develop applications for: process monitoring, security, network security, and application specific security. Here I'm specifically concentrating on application specific security and a bit of process monitoring. I don't know how to categorize this, but this comes under these two. Definitely it's not a network security part. The application that I'm going to show you completely on process monitoring and application specific security. And I don't know whether you have gone through my previous video. There I have shown how we can do the process monitoring with system by monitoring system calls, especially the system enter exec v system call. Yeah, these are some challenges. Of course, the complexity that I'm going through each day, it's each day there will be something new that you will go through, the challenge. And yeah, you have to spend a lot of time to figure it out how it works, because there are very less eBPF programming resources. And yeah, especially when you are trying to do both side on C, like kernel and user space application C, it's pretty difficult. Not difficulties in the sense, not C is a challenge, but eBPF restricted C is really a challenge. And of course there are security risks, because eBPF themselves needs higher privileges, so you should be careful. And yeah, and compatibility is another issue. Like even though the compile once and run everywhere concept is there, but still I haven't explored that area. So yeah, definitely there's compatibility issue if you are developing a normal application without considering the core concept. Yeah, these are some useful links that I will show you while going through the program. Let us dive into the program now. And this is my LSM? Yeah, LSM hook. Actually, I had a lot of failed attempts before that. I tried to achieve this using normal tracing. Like I tried. This is a normal system call that gets called when a file is getting deleted. Unfortunately, I couldn't find my function, like I couldn't implement my logic here, because the way it works is entirely different from the LSM modules hook point I used. And the other challenge was there were a lot of structures involved, and all these data types had to paid a lot for me. Like, the size of the stack is very limited in eBPF, and if your struct is going beyond that, the eBPF verifier will reject your application. And I did stuck on this normal trace points is called at least for 3 days, and later I moved to my actual interested area of security. So then it was pretty easy compared to the other one. Let me show you my program. Yeah, this is an application, and here, hope you know all the structure of this one. You should mention your license section in the eBPF for the verifier. And here, last video I mentioned that I would be sharing how we can make use of eBPF maps. Here it is needed because I am sharing the eBPF data from the kernel space to user space. So definitely I need maps to do that. And maps is a mechanism in eBPF that helps us to share data from the kernel space to user space, and from there to here. And here I'm just sharing one side from kernel space to user space. And this is a main thing. This is the area that I was mentioning when I was talking about LSM. This is a hook point. I'm going to put a hook on here, path unlink, and this is a hook that gets called every time when some deleting operation happens in a system. So again, the challenge for this one is these parameters. Definitely this is a challenge, but once you're familiar with this one, this will be easy for you. And here I did spend a lot of time to figure it out, but yeah, there are some good documentation available if you search in Google. ChatGPTs may be helpful, but yeah, it actually most of the time ChatGPT was telling me that eBPF is a complicated stuff, so it can't produce accurate results for most of the stuff. So the best part was, as just mentioning here, this website, elixbootlink.com, they had a very good documentation about the Linux kernel part. So you can go there and search for this one, how you can find out the parameters for this the hook point I used, and everything is defined here in this header file, and I'm making it easy for you because you can directly go there and search it. And it was very difficult for me to find out initially where the actual definition goes to find out the exact matching parameters for this hooking point. And here you have everything, every hooking point mentioned here. You can, and just be careful, this is for version 6.2, and if you want to go to your specific version, you can directly go there and search from here on the left side tree structure. And here the point I want to share you is path and link. Oh no. Okay, definitely it is here. You can I was planning to search common on the browser. Let me search on the browser. Link. See, this is a hook point I used, and if you see, you can see the parameters. Like, definitely that the first one should be your function name, the hook point name where you want to put your hook, and these are the other parameters. Actually, you can just copy directly from here and use it in your program. The only difference I made here is I just made this parameter renamed as a d-entry argument instead of the same name. That's the only difference I made, and this is the easiest way to find out which parameters you have to use with the hooks. And here is another thing, the previous video, I don't know whether you noticed that one, you could have your name, your custom name here instead of the BPF program macro. But here in LSM, it should be this one, because when I tried with the other way, it was complaining it was not compiling. And yeah, this is the way it works. And this macro is an entry point for this eBPF program, kind of entry point. So it should be always this one. Even if you have multiple hooks, everything should be starting with a BPF program, especially when you're using LSM hooks. And here, another thing you have to be familiar should be like what are these data structures. And I hope you remember last time I showed how and where these data, you can find out details about these data structures. As an example, hope you remember that we dumped all the available data structures and every kernel related functions, kernel related stuffs here in this header file. So if you search here, you can easily find out where and what this structure is pointing out. Actually, it's kind of cache directory cache entry or something that points to the actual inode. Here it has a pointer to the inode, and inode is basically it's a base of all the VFS file system in Linux. It has all the metadata or the actual file data that points out all the files. Like, all the files means every files will have its own inodes, and there are some difference when it comes to soft links and hard links. So you just search for that. And I'm saying that you should be familiar with all these stuff, especially the structures that we are going to make use of to find out what we are going to access. And here I'm accessing this name because this has the value that I wanted to have, one of the values. If you search here, I'm taking my file name as from the d-entry value here. So this here, this structure will have the file that is being deleted when this hooking on this hook point. So you will get the file name that is being deleted from this part. you can access. You know why I'm using this dictionary, this operator? Because it's a dictionary, this parameter is a pointer in fact. And if you notice that the other name I access using a dot, it is not a pointer notation. Why? Because if you check, if you come here first, this d underscore name here in VM Linux, see, this is a structure. This is another structure that is not a pointer. If you see here, the d-entry of parent is a pointer. You can see the star here, and this is not a pointer. And this is another structure. If you want to normally access the structure's members, you have to use the dot notation to get it. And if you want to see what exactly here inside this one, you can directly come here and see what exactly it has. See, it has a union inside that and another name. So this name is the one that we access here from the structure, and we are accessing using the dot notation because this structure, the second structure, the d underscore name, is not a pointer. So we will be getting the file name that is being deleted from this parameter. And this is another part that I use. This is a function that we have to use for getting reading this value from the kernel to the variables that I have created here. So regarding this event data structure, I have these the members. Like I have the PID. I have to store the PID. I'm taking the parent process ID and the user ID. Then exe name means when a malware is getting deleted, if it's a self-deleting malware, the file is being deleted and the exe name will be same. Suppose if it's done using some command like rm-f, then or whatever operation that you are using, then in that case the exe name will be rm and the file name will be the actual file that is getting deleted. Yeah, those things you should be aware about that when you are developing these kind of stuff. And this is a thing that I was telling you regarding the structure. I'm currently using ring buffer map. There are other maps available, but for this one, this is the best one because you just search for how the ring buffers works, and this is one of the most optimized maps for this kind of operations. And this is a way you have to declare that you have to, and this is a so on some other older versions of books I have seen some other way like BPF, some BPF functions to declare that, but the modern eBPF apps, when I was searching, everything was declared using this syntax. And this is a map macro that I'm mentioning. This is going to create as a ring buffer, and this is a actually is equal to 1 MB. And you know, if you're a C programmer, you know how efficient of having the shift of operators other than mentioning high number there. And this map will go to the map section of my eBPF. So what I'm basically doing is I'm creating a memory for my map using ring buffer reserve, and I'm passing my actual structure for that represents my ring buffer. And here is the main thing, that map ring buffer should be the size of my struct that I have created here. It should hold all these values. And the last one is a flag, and again that flag, please refer this function and you will get details about this one, how these flags works. And as per the documentation I have seen, this is the safest flag that you can make use of. There are other advanced flags, but it has some, I don't know, you just go through the documentation, definitely will be end up with 0 for at least as a beginner. I have to stay with that. And I'm checking if something is, if the memories are allocated for me. If it's not, I'm just returning the program. And this is another eBPF BPF helper function that helps us to get the current command name. Command name in the sense, and if you check here, there is something else I can show you. The command name has a value of max length of 16, and the file length has value of 256. That's a built-in stuff in Linux. I don't know why it is restricted to 16, and I will show you how you can find it out. But this is a helper function that helps us to get that command name into the current command name into this field. So that's a string having 16 kind of, it's an array of characters that is having 16 length. And here is the main thing, like I'm getting the current task struct here. That's important here. You should get the current task struct here, because if you don't have this one, you don't get much of the data that we are planning to get. Like the file name, yeah, I will tell you how exactly you have to get into this one. Okay, just imagine that you are getting the current, all the process information. The task struct has all the process information, or thread, whatever it is. It's one of the main structures in in Linux. There you get almost every information about the process that you are in. So if you go here, you can see it's a very huge structure, and I think you can see somewhere. This is a command, current command. So that's the reason we always declare with the number 16 characters for this command array. And to get this one, and my aim was to get the exe name that's getting called to delete this file. So as I mentioned, when we're using a command like rm to delete some file, so the exe name will be rm. So to get that rm file, you have to travel like this, and for that I'm getting this bt. Actually, the another thing you can see is, I don't know whether it's a new function that returns to the eBPF type data, because the examples I have seen on other websites, or if you search for that, normally they use this task and they convert back to task struct here. But for an experiment, I used this one and it worked well for me. And that's a way, like that's another thing, like when you're trying to get access to the actual exe name, it's bit trickier. Like the exe name is inside another one, like this So go to this one, and just instead of task, and if you come here, you can see inside here we have it's pretty difficult to find it out. It is somewhere here. You have to find it out. The best part is I can share from where did I get this. Just for my reference, I just confirm here, like how it is referring to. I don't know. Maybe. Okay, the easiest way is, if you want, you can just copy paste this to somewhere else and check it. But I have one place. This is really a good resource. He explains how the eBPF core functions works. And if you paste this here, he explains how we can get all these stuffs, especially BPF core read, and he explains the differences. It is pretty neat and understandable. Suppose if you are doing a normal application development, like a Linux kernel module, you will get the exe name like this, because this is a task struct that's created here, and inside that there is an and struct, and inside that then another structure, and it goes like this if you want to get the file name, exe name. And it's pretty straightforward in kernel module, but if you want to read it using eBPF program, you can't do that directly. You can't do that. Instead, you have to access it using this one, BPF core read. I tried this method, but the problem was I was getting a Linux segmentation fault when I was trying to load it in user space. So after a bit more research, I ended up with this function in my that helps me to read the actual exe name and the file name. There may be other way of doing it. I tried here using this one, and the other difference was when I was trying this one, if you notice this, the data type is returning is a constant unsigned character pointer. But here I'm using, when I was using that one, I was getting a segmentation fault in user space application. Then I was searching, and I got from somewhere that it's better to use this character arrays. Even when I was using character arrays, I'm facing some other issues, like is not printing exact ASCII characters. But I think the padding of the array, because it's 256, maybe the padding is filled with something else, then it's showing all the junk characters when it's trying to print it to the console. In short, actually this is a way you have to get the exe name from the current task struct. Then you will get the file being deleted from the dendry struct. And then the logic is like, I'm just sending this information to the user space application, and I'm comparing the exe name and the file is being deleted on the user space application. Note here, that was another challenge that I was facing. You are not allowed to use any kind of loops or string comparison functions here. Even though there is a function BPF string and CMB something, when I tried to use, I was getting, the verifier was rejecting my application by saying I was trying to only read-only variables were allowed on that string comparison provided by BPF. I didn't get what exactly it meant by. I tried different methods by using different type of variables, but nothing worked out. So I completely moved out the logic of checking the exe name and the file name on the user space. So these are the things that we are fetching, and this is a normal print. I will show you how it works on different areas. And one more thing is, I had developed a self-deleting application as a part of, originally it was developed as a part of Golang Pro application I was developing, kind of attack simulation stuff. And this was a simplest code for, it's very simple to do that. You just call the unlink syscall, and it is very it's straightforward application. For this purpose, because I'm trying to better my knowledge in C, I converted that to C, and here is the same thing, like nothing fancy on this one. You all know this is the first argument is always the exe name itself, so I'm just taking that and just passing to this function, and here it just calls the same thing that I was doing in my Golang, just calls the unlink, and that's it. And when you're trying to unlink from the application itself, even though it unlink that file from where you're calling the unlink, but still the process will get access to that. That's why I just print out this message here. So the deletion, even though the file is getting deleted from there, still you have the current process that initiated the unlink, you will have access to the process, so you can continue your operation even after doing that. So you can do something before the deletion, and you can because you have still you have control over the process, you can again do that all the malicious stuff you want. Then you can, when the program finishes, it's completely deleted from the disk. So this is a program for that, and I already showed my eBPF program. So let me show you how can we run this one. First I will show you how without the normal way of doing this one. So here I'm just compiling this one. I created one self-deleting application, and I'm just copying, just making it 2 because I want to I will show you how I checked this stuff. So the next thing is I have already on the last video I have shown how the makefile works for this one, and I'm just deleting my old one, and I'm creating my eBPF program. So the eBPF program is done, and now here there are 2 things. First I will show what is going on the tracing point, trace pipe, and then we will go to our customized eBPF app, user space app. So for that, the first thing I'm going to create is the skeleton file from the eBPF program that we developed. Like basically we are going to create a skeleton from this one. I explained all these stuff in the first video, so if you have some doubt, just go and refer that. I'm just creating a loader for that. And the next thing is I have a default loader.c that I was using on my last program for the normal trace point. Basically we just open the object and load the eBPF object and attach it. That's it. And all these things are defined inside the skeleton header file, so it is easy. You can just directly include it and call it there. So after that I'm going to compile this normal loader, and yeah, of course you didn't need the pseudo privilege for this one. So I'm just running it here, and let us verify the pipe. I think the pipe has all data. Yeah, now still it is all these the Chrome, the Chromium one, the Visual Studio Chromium, the code, VS Code, this one Codium, and this is doing a lot of things are going behind this stuff. It's doing a lot of temporary deletion. You can see all these things. This is another beauty of these eBPF apps. You can trace out everything. So whenever some deleting operation happens, this hook is getting called, and you can verify everything basically. The only problem is when you are getting this much of prints, it's pretty difficult to find out our applications. Okay, let's try to do that. The first thing I'm going to do is I'm going to do the self delete is that? Let me check. Certainly 2, and yeah, there are 2. I'm going to remove -f and this one. And if you see on this window, you can see, yeah, this is going to be a challenge. And because the Chrome I have opened it for, the Chromium application I have opened for a long time, this is doing a lot of temporary deleting stuffs behind the scene. And the thing we have to find out is, where is our, yeah, here you can see the rm. See, the current command is rm and the current exe name is rm, but you can see the file name, the current file name being deleted is the file name that we pass the parameter to rm. So here there is a difference. The exe name is rm. Actually, rm initiated the deletion, and you can see the file deleted, we access it using the d entry, and the file is being deleted is this actual file name, and the command and the exe is always rm because we deleted using the rm command. Now the self delete option, let's try that. So the unlink got called, and yeah, the program finished, and here it should get the same details. Okay, because of the Chromium is doing a lot of unwanted stuff. I don't know, it is deleting a lot of stuff behind the scene, a lot of temporary files. See, here it starts. The current file is being deleted is see, this was the gen characters I was telling, because the character array has 256 and it is padded with some these kind of values. I have to find out a way to figure it out, how to remove these stuff from here. The file is being deleted is self delete 2, and the current exe is self delete 2. That means it is trying to delete itself. So when that happens, these two names will be same. Of course, the command is always the same. Why I didn't use the command is because it has a limit of 16 length, and suppose if the file name is more than that, you won't get the actual file name for that. That's the reason I was getting the exe name, the actual exe name that is initiated the deletion using the struct and we went to in detail about the file path, and from there we went to the d entry, then inside that we took the file name. That will be always accurate. So this is what happening when you are normally loading this app. So the next thing what we are going to do is, we don't do any we are not going to check the pipes anymore. Instead we are going to run our own custom loader. So for the custom loader, there are other stuffs we have to do. As I was saying in the beginning, we are using a ring buffer map that shares data between the kernel space and user space application. So we have to access that, and we have to ensure that is getting, our data is getting on the user space and process on the data. So again, this is done in C, the user space app, but of course there are some problems on C that I will show you that, then you will identify the issues on that. So this is my custom code that I'm using. So here, yeah, of course I'm using the skeleton file, and I got the effective use of ring buffer from another site. That was this one, and here it has a clear working example that helps you to work with ring buffers. Okay. somewhere here you'll find out, is it ring buffer? Not ring buffer. Yeah, it is. Yeah, this is the same thing. Here they put created the eBPF app using the ring buffer, and they're sharing the data to the user space. But I have done in a different way. But here you can see that they are using this BPF core read method instead of the one that I used in my app, and they are creating space for their ring buffer, and finally they are submitting their ring buffer to the user space. So once the submission is successful, you can access the data to the user space app. So what happens in user space is, like, I'll show, they have a sample that shows how to access the user space. Don't get panic on this code. The main area that I need was very less in this one. Yeah, actually they are loading, they're using the bootstrap BPF. This is another library. If you want, you can check this makes you easier to do that, but yeah, definitely it blocks understanding of actual how the eBPF works. That's what I felt, so that's why I didn't use this one. But basically it is just they did created the skeleton file, and they are just loading the object, and after that they are attaching it, just like I'm doing in my program. And here is the main part. You should set a polling for the ring buffer. The polling in the sense, when the submission happens there, you have to find that here in the user space. So for that, actually we are using this polling method, and there is a this is the way you have to access your map file descriptor from the skeleton object that you have created. Actually, this is nothing but the name that basically refers to the name that you created in your ring buffer, and that is where, I mean, if you are trying to do it manually, I tried it, but it didn't work. I don't know why. I tried to manually loaded this one using this name, and I got a file descriptor, but I don't know, for some reason it didn't work well. That's then I was searching for some help, and I got this one, and this perfectly worked. And once if you get the file descriptor for the map, we are attaching this method handle event, and this handle event should be defined here. Yeah, here. And here we are actually dealing our logic, and this is something else here they are doing. But in my app, actually what I'm doing the same thing. My custom loader is here. I have more simplified version for me. As usual, we just open our loader like the previous one, and load it, attach it. After attaching it, actually I'm doing the same thing. I'm creating a polling for this one, like attaching to an event. Whenever the submission happens, that struct details comes here, and that struct has these information. So when the struct comes here, it calls this method, and that has the context pointer and data pointer and the size of the data that is coming through this event. And since this is a void data pointer, you can convert that to any pointer. So I'm just converting this struct event data is actually it is not defined here, that's why it's showing like this. The thing is, you have to add this here in your user space. So whatever you are using here, it should be the same struct that you have to use it here. So I'm copying this one to my custom loader. So instead of I'm going to use it there inside the loader C, I'm going to place it in my header file, so I can make use because it's already included in my custom loader. If you check here, I already included here. So just adding my struct here, I will get access to that. So now I have the event data structure that is defined inside the loader file, and I'm just converting that. Here I'm checking whether it has all the data is submitted or not. If there is any because this size data, if it's less than the actual event, the actual struct that I'm getting, then it should be having some issue of in the ring submissions, buffer submission. So I'm just returning that. So if that's not the case, I'm using the most vulnerable comparison, and definitely this is not recommended. But yeah, it's in C, so I have to find it. Definitely I'm going to move this to Golang, like the user space app using Cilium. So in that case, it will be more secure. But for this purpose, just I'm starting with C. I have to compare this my exe name and file name and the max length I'm supplying, and if it's matching, I'm saying a self deletion attempt detected, and I'm printing the details here. That's it. That's the only difference between the normal loader and the map added loader. Like here we are taking the data from the kernel-space app. When the eBPF app submits the ring buffer, and we are fetching it using a polling function, attaching that event using handle event function, and we are getting the data. And here this I have taken from the one that I showed. Just breaking house, we can break it, like basically you can do the controls. Even if you don't add this, you can control C and break it, but this is a good way to do it like more elegantly. So what we are going to do is we are going to run this app. We are going to try. We already made the skeleton. Here we are going to create the loader. See, now I'm using my makefile because I just did this one just for the demo, like how the normal application works in eBPF and how it is performing the getting the file names and exe names in the kernel side. And we have no control over the map here because we are not using the map in this one. So the next one, the custom loader, I have the map. So here the crucial point, I have to come here and let me create my self delete application here. And did I copy that? Yeah, I have two apps there, and here I'm going to run my custom loader. What was that? Did I create the loader? I think the name I have mentioned inside the make file. Let me check. Oh, this was user space. Okay, this was the name I mentioned there inside my make file. I got confused on that. Okay, let us run this app, and if it has no error, this will run like this. And now we are continuously listening for the map submissions. And suppose here the first thing I'm going to do is -f self delete dot self delete dot, and see we didn't get any message here because the rm, we use the rm command to delete it. But if we are going to do this one, this application is going to delete itself. So here theoretically I should get a message here, and I always before the demo I checked it, it was working, and I am expecting the same here. See, I got it. Like now we have a kind of, it's not EDR I say, but a kind of detection mechanism that we implemented in eBPF that hooks one of the LSM hooking points and detects a malware behavior, like whether a function is doing, whether a file is initiating a self deletion process. And here you see the file name, the command is using, the executable file name is same, and the file is being deleted as same. And yeah, of course, the next updated version I had to remove these junk characters, and I think it will be easy, it won't be that much hard. And definitely the next updated version will be, I'm going to check the Cilium Go part, because I hope you did understand the issues of the loader, the C, what I was doing here. See here, yeah, this is a well-known vulnerable string comparison function, and yeah, it has its own limitations. So yeah, that's all on this video. This is what I planned for. Actually, I'm behind this for I think, yeah, nearly a week, because I started, as I mentioned, I started with normal trace point context, and but I was not able to do that because of the hook point, the normal underlying hook point was not getting called on certain scenarios. And then the next available thing was I had to go with the kernel probes, and that even is not a good idea. Then I moved to my favorite security part of this eBPF, and yeah, I tried LSM, and this works perfectly. It works, and this is the one I was planning, and definitely I'm going to develop more on this one, like how we can hook on other functions, and how to detect, or maybe you can add prevention also. That's what I think. And that's all for this video, and thanks for listening. We'll see you soon with another eBPF programming tutorials. I know it's a bit complicated for someone who is listening first time, but believe me, if you spend some time on this one, this is really an amazing technology, and you will get addicted to this. So happy programming. See you soon.